Hi, welcome to this week's challenge problem. In case you have not solved this problem earlier, please pause the video and give it a try. For those who have already tried, here is the solution to this problem. This is a percentage problem and we have to find the value of x. It actually has two parts to it. One is to deal with the percentage, and then there is going to be an equation that we have to solve, and that will be the second part of the problem. Let's get started first with the percentage. Let's say this watermelon has weight m, that is the absolute weight of this watermelon, and it is going to be split into two parts. One is the water content and the other one is the solid. And the problem says the content of water is x percentage. So that is x over 100 times m, right? Now the solid is obviously going to be 100 minus x, that is the percentage. So the absolute quantity is going to be that divided by 100, that is the fractional part, times m. So that is the actual weight of the solid. Then it says when the fruit is kept under sun, it loses x minus 5% of its water. Now we are dealing with percentage of percentage. So this itself is obtained from applying a percentage x on the total weight of the fruit. Now we're going to do percentage of this. It's going to be x minus 5% of this water content. So we're going to have, again, two parts to it. One is the lost, and this is going to be the remaining water. So what is lost is x minus 5%. So x minus 5 divided by 100, that is the percentage of this water content. So we have to put that here, x over 100 times m. So this is the absolute amount of water that is lost from this fruit which had a mass m. Now what is going to remain is the original water content minus the water that is lost. So we just simply have to subtract it, x over 100 m minus x minus 5 over 100 times x over m, or sorry, x over 100 times m. All right, now if you look at this tree diagram, what we have here is the original water content, and what we have here is the solid. So initially this fruit that had mass m was made of these two, water and solid. And then after keeping it under sun, some amount of water is lost, and then the remaining water content is this. So now the fruit is made of this water content and this solid. The solid, of course, remains the same. Now, if you compare these two, the remaining water content and the solid, the problem says the content by weight of water is now 50%. That means it's equal to the solid. So we can equate these two, the remaining water and the original solid. Let's write that as an equation. X over 100m minus x minus 5 over 100 times x over 100 times m is equal to the solid part, which is 100 minus x over 100 times m. And we can see that every term has m in it, so we can cancel that, and we can also multiply this entire equation by 10,000, which is 100 times 100, so that we can get rid of all the denominators. So we're going to get 100x minus x minus 5 times x equals 100 times 100 minus x. All right, now we remove the brackets, so we're going to have 100x minus x squared plus 5x. We have to be careful with the negative signs. When we do the distributive property, we have minus x squared, and then minus of minus is plus 5x, so we get plus 5x here, and that's going to be equal to, again, distributive property, 100 times 100 is 10,000 minus 100x. Okay, there are several x terms which can all be grouped together, and then there is the x squared, actually a negative x squared. So let's move everything to the right side and write the equation as x squared we have a minus 100x, and then this 100x also becomes minus 100x when it moves to the right side. And then we have the 5x, which also becomes minus 5x. So overall, we're going to have minus 205x. And then we have this 10,000 equals 0. This is the quadratic that we need to solve now to find the value of x. So this completes the first part. And now let's solve this quadratic. X squared minus 205x plus 10,000 is equal to 0. There are a few ways to do it. We can do completing the square, or we can assume a factor form like this: x minus p times x minus q is equal to 0. And now we have to find the value for p and q. And we can simply expand this form: x squared minus of p plus q times x plus pq equals 0. And we can compare term by term. This minus 205 is equal to minus of p plus q, and then this 10,000 will be equal to pq. And so we have two equations: p plus q is equal to 205 and pq is equal to 10,000. We can start with this 10,000 and find two products which will give 10,000. One easy product is 100 times 100, but the problem with this is 100 plus 100 is not 205, it's only 200. So let's make another attempt and finding the two products. Can we write it as 90 times something? 10,000 will not be divisible by 90, so let's try 80. Yes, 80 will divide 10,000. 80 times 10,000 by 80 is 1,000 by 8. 1,000 by 8 is 125. And this indeed works out because 80 plus 125 is going to be 205, which satisfies this first equation. So we found the values of p and q, and so we can go and put it back into this factor form right here. So we're going to have x minus 80 times x minus 125 is equal to 0. That means either one of these two products should be 0, which means x must be 80 or 125. Now, we started off with x% of water content. That means x cannot be greater than 100. The entire watermelon fruit has both water and solid, and water cannot exceed 100%. That means this solution 125 is not possible. So we are left with x equal to 80 as the solution. Now, having worked out the problem, we can go and substitute this value of x into the problem and check whether it makes sense. Let's try that out. It's always a good practice to go and verify our solution, especially if it's an algebra problem. We can put back the value of x that we found into the question and see whether it makes sense. So let's try that out here. If the original fruit is, say, 100 grams, just for ease of calculation, we can assume it is 100 grams. Now, x% of that is 80%, which is 80 grams. So that is the water content, and the solid will then be 20 grams. X minus 5% of the water, that is 80 minus 5, 75%. So the amount of water that is lost is 75% of this 80 grams. Then obviously the water that remaining water is going to be 25% of this 80 grams. So 25% of 80 grams. Let's calculate both of these. 75% of 80 is 75 over 100 times 80. That is 3/4 of 80, that is 60 grams. And so this will obviously be then 20 grams. 80 minus 60 is 20 grams. Now, what has happened is the original fruit, 100 grams of weight, it lost water. It lost 60 grams of water when it was exposed to sun. And so there is remaining 20 grams of water. And notice that this 20 grams of water is exactly equal to the 20 grams of solid. That means these two are 50% each. Now this 50% is for the new weight of the fruit, not the original 100 grams. The fruit is no longer 100 grams now, it's only 40 grams because 60 grams of water is lost. In that 40 grams, this water content that is remaining is equal to the solid content that is remaining. Both of them are 20 grams. So that confirms that our answer is correct. Thank you very much for watching, and please try the next challenge problem. Hope you enjoyed this video and have a nice day.